Hello and welcome. In this video, we are going to learn how to scrape a web page with pagination. We are going to scrape a website that was created to practice and learn scraping. We will extract information from the books in this fiction category. The challenge is that we need to use pagination to scrape all the books. We want to get the name of the book, the price of the book, and the stock availability. The stock availability is displayed only when you click on the book name and visit the book's detail page. After gathering this information, we will input it into the Google spreadsheet here. We can now start building our flow. Let's return to the Flow Designer and begin by adding an inject node to the flow, then rename it to Start. We can then proceed with the flow by using the web recorder. Let's first start by getting the book name. Repeat this on the next book. And then let's get the link of this book. Then the price of this book. And let's check the scraped list. When we check the list, we see that the title name is not full. So this means we need to get this title from somewhere else. Let's delete this. And let's try the alt text of the book images. Right-click on it. Find the alt attribute, and this seems like the full title. Repeat it for the next book. Let's check it now. This old title here does not seem to be deleted. So let's try deleting the old title column again. And when we return, we can now see the titles, the prices, and the links of the books. Finally, before returning to the flow, we should rename the columns one by one. We can name them Link, Price, and Book. Save it, close it, and then finish the web recording session to return to the Flow Designer. Now let's rename the recorded subflow to Books. Connect the inject node to the Books subflow and then add a debug node after it to observe the captured list in the debug output. We can now run the flow to check our progress so far. Ensure that a robot is connected. I prefer to connect the robot from the terminal, but you can also connect it from the RoboMotion desktop application. Then we are ready to run our flow. If you check this debug option, the output will be nicely indented in the terminal. The page has been opened, and as you can see, we have scraped the list of books and retrieved the titles, links, and prices. The output is in a table structure with columns and rows. Now let's proceed by first adding this table to the Google Sheets. We need to rearrange the subflow to make scraping all the pages easier. We can cut the recorded nodes within the subflow and then paste them to the main flow. Add the Open Spreadsheet node and set the URL using the link from our Open Google Spreadsheet page. Then select the credentials. After obtaining the scraped list in a table structure as output, we can add it within a specified range using the Set Range node. Be careful to select the correct Set Range node from the Google Sheets package and not the Excel package. Let's also select the Headers option and see if the flow works. As you can see, the scraped list has been pasted into Google Sheets. Now we can proceed by clicking the Next Page button to continue scraping all the books. The Next Page button is located at the end of the Books page. Add a Click Element node to click the next button in the page. Select the Inspect Element option from the Node Action menu. Hover your mouse over to the Next button. Right-click and select Single Click. The selector used looks okay. Save it, and you can see it as returned to the node properties. Now after this Click Element node, we have to add the Scrape List node to scrape the next page. Then we need to use the Append Range node to append the scraped list from the next page into our Google Sheets. We also need to continue clicking the Next Page button. To do that, we need to return back to the Click Element node, so we can use the Go To and Label nodes here to create a loop. We can also rename this label node as Next Page. Then we need to select this node in the Go To node properties. After that, we can run the flow again. We should also delete the Google Sheets data before starting the flow. As you can see, the Next Page button is being clicked. However, on the final page, we should see an error when we return back to the Flow Designer. Because there is no Next button on the final page, the Click Element node will fail. We can use this as a signal to stop scraping. So let's continue building our flow. When we encounter this error, we can use a catch node to recognize it as the final page and then stop our flow because we have scraped all the books in this category. Add a catch node to the flow, then add a stop node after it. We have fixed the error handling. We can also rename the Click Element node to Click Next. With these changes, we can now scrape all the books and stop the flow on the final page. Our next task is to visit each book's detail page to get the stock availability information. Currently, our Google Sheet has the links, prices, and book names, but it doesn't have a stock availability column. Let's widen these columns and then add a stock availability column. We can add a stock column next to books here, but first we need to fix the book URLs. This is the link that we retrieved from the page, and this is a relative URL. So we need to fix this and convert to an absolute link. Let's go back to the Books page, click on any book to visit its link, and then observe the full URL. So the correct URL should look like this. However, our URL is a relative one and contains dots and slashes. Therefore, we need to replace these dots with the base URL. Before adding this to our flow, we can manually replace and test a link. So let's test with this one. Let's change this. This link now looks correct when compared to a visited page. So let's copy and test it. It works. So with the manual replacement, we've confirmed it's working. Now we should replace these dots and slashes with the base URL within the flow. So let's do that. We can use a function node to replace the link properties of each JSON element within the table rows array. Add a function node here, and then connect it. Rename it to Replace. We will update the table rows under the message object. As you can see, it is table.rows. This is an array of JSON objects that contains the cell values for each row. So, we will update the message table rows within the function node. We'll use the map function in JavaScript to accomplish this. We can write the returned values to the same rows as new values. The map function applies a transformation to every element in this array. In our case, we want to replace the link values. After the map function, we can use item as a parameter name for each iterated element in the array, and then replace the link property accordingly. But let's ask ChatGPT to do this for us. Then we can use the generated code in our function node. Let's ask it to complete our code, or better ask, fix or complete the below code. Then copy and paste our code here into the prompt. You can also ask it to write the code from scratch. We can then copy the code from here and paste the generated code. However, before starting the flow, we need to clean up the Google Sheets from the previous data so that we can start from scratch. After that, we will return to the Flow Designer and run the flow. Let's also close any unused tabs. Finally, before running the flow, we need to add the replace function before the next page scrape list node. The same requirement applies here. Now we can run the flow and see if it works correctly. Click the Run button and wait for the scraping to finish. Once everything is done, we will check the Google Sheets. The link replacement for the first page seems did not work. We can investigate and understand why it failed. We can also pick any of these links and test to see if they work. It seems to be working. And here the problem seems to be wrong order. We have to place the setRange node after the replace function. Let's clear the Google Sheets again before starting the flow. We have successfully finished scraping all the books. The first page link replacement bug also seems to be fixed. Now we can continue building our flow. We will continue by moving the working parts into a subflow to keep things separated. For better flow design, each subflow should handle a single task. Since we are moving this logic, we won't use the stop node here. So let's cut this part to paste it into a subflow, and we'll call this subflow Scrape All. Now, after the catch, we will end the subflow. We are now capable of scraping all the books, and our goal is to gather specific information for each book from its individual detail page. We have the links to these book detail pages, which are stored in our Google Sheets document. We will visit each of these links and extract information of the stock availability directly from the text on the page. To organize this information, we can introduce a new column in the Google Sheets document right next to the book column. To add a new column, we can use a set cell value node after the scrape all subflow. Adding a column is as simple as setting the value of D1 to stock. Therefore, we need to set D1 as the value in the cell property of the set cell value node, and then set stock as the cell value property. After that, we can add a get range node to read all the values in our spreadsheet. We will use the output of get range to iterate with the for each node. The get range node outputs a message table object with all the rows from the sheet, allowing us to iterate through them. We should select the header option when a sheet has headers, and also choose JSONify to create JSON-friendly row keys. Let's put a debug node here to observe the get range output. Clear the Google Sheets document to start from scratch and run the flow. We are still scraping. Double-click to check the progress in the subflow. Here, we caught the error, and thus scraping is finished. Now, the debug node after getRange should dump all the sheet rows. When we scroll down here, we should see the JSONified values returned from the getRange node. Now, we need to visit each of these pages and fill out this stock column. For that, we can use a for each loop on the rows returned. And then add an open link node after for each. We have now started iterating through each row returned from the getRange node. Let's set the properties for the for each loop. The object we are iterating over is table.rows, so we should set that. Then for the current item, we can name it row. Index field is optional, but let's add it. And now we will try to fill this stock field by visiting the link in each row. We will visit each link and scrape the stock availability. Let's return to the open link properties and first set the open in the same tab option. Then, let's set the URL property using message.row.link. Message.row represents the current item being iterated in the array, which is the output of the for each loop. Do not confuse this with message.rows. It is the current iterated item, which is message.row. Message.row comes from the for each node here. So the message.row.link is the right value here. We now need to scrape the stock availability text from the page. For that, we can use a getValue node. GetValue node requires an XPath selector. Click the Inspect Element option from the node menu. Select the text attribute of the text element on the page. It should select the P element. So let's try using this class attribute. The recorder should find a selector that returns only one element on the page. However, with these selector options, it appears there are 7 elements on the page that match this XPath. So we should continue trying. Let's uncheck this P class attribute. This looks fine at first glance, but it is the parent of the P element, which would return unrelated text. Let's use Chrome Inspect to understand the page layout. Now we have a working XPath. We can now return to the Flow Designer and then try our XPath with the getValue node. Let's hide this image with the Hide Preview option and paste our XPath we have manually created and tested in the Chrome Inspect tool. So we get the value now, the stock price value, and we want to set this to set cell value. We can utilize the index value of the for each node in the set cell value to create the cell coordinates. Let's switch to the Google Sheets tab now. We want to write the stock availability values starting from the D2 cell here. So index +2 would point to the right row number. and we can use the text returned from the getValue node here for the value field of the setCellValue. We can use the JavaScript scope to generate our dynamic dCell coordinates by combining a static D character with a dynamically incrementing index value. Start with a backtick operator, add a D character, and then add the index variable +2 using a $ and curly braces. Finally, close with backtick. We can add a stop node after the for each node to stop our flow after scraping all the detail pages. To continue iterating with the for each node, we must return to the beginning of the for each node after executing the setCellValue node. To accomplish this, we can add a goTo node after the setCellValue node and a label node before the for each node. We can rename the label to nextLink, and then we should check which label to jump to from the goTo node before running the flow. Before clicking the Run button, we should clear Google Sheets. Then we can continue running the flow. It will first start scraping all the books, and then the flow will continue scraping each detail page. So the flow failed and threw an exception. It seems that we made the classic mistake of adding a node from another package with the same name. Instead of using the setCellValue node from Google Sheets, we added the Excel nodes. Let's fix that, and then start setting the properties. Let's re-enter the JavaScript scope value as we did before, enclosed in backticks. We will concatenate the static D string with a dynamic message.index +2 to create cell coordinates. Create the dynamic part using the variable within $ and curly braces, and close it with a backtick. Again, the flow failed with the setCellValue node. This time we used the correct node, but the problem appears to be that the message.value field is empty. We can verify this from the debug output. It seems that if the value is empty, then the getValue node's XPath selector does not work. So let's try again to find the right XPath selector with the inspect element. We should include the P element with this attribute, but then it matches 7 elements. Let's try to narrow it with its parent attributes. Now this looks promising, and it matches 1 element in the page. Let's try again with this updated XPath. Run the flow and see if we can solve the problem. Pagination is working. We have failed to retrieve the value again. Let's try to identify the problem. The problem is that for P elements, the text attribute will not return anything. The recorder should not have returned or added it, but only the P element itself. Let's try removing the text attribute here and retry. So this should now work. Clear the sheets again. Okay, finally, it seems to be working. The flow has started visiting each page and has begun adding the scraped stock availability text. We are writing the text as it is returned from the page. However, it would be better to write only the numerical value. We can use ChatGPT again to write code for us that extracts this value with some regex. The generated code uses regex to extract the numeric value from the text as desired. We can use these parts we need in a function node. We can place a function node here that extracts the numerical value before the setCellValue node. We can rename this function node. Let's rename it to getStockAvailability. We can use the regex we copied from the ChatGPT output. To recap, we use a regex to find numbers within a string, and the match function returns an array named match. If it is not empty and it has a second item, we use it to parse into an integer. If the regex match operation on the string cannot find any numbers in the text, message.value should be 0. We can now clear the sheets and then run the flow again. As you can see, we are now parsing the stock availability and adding it numerically. This involves visiting each page, retrieving the stock availability text, and then entering the parsed value into the cell coordinate determined by the current row index being iterated. The flow completed successfully. In this tutorial, we learned how to scrape a web page with pagination and how to use the function node to process data where necessary. Thank you for watching.